If we didn't do that, things would run much, much slower. So every game needs something called a main game loop. Okay, and this is where basically all the meat and potatoes of your game goes to. So we're going to make a loop while true. Now I'm going to put 4 spaces there. You can use tabs, but spaces are recommended. But whatever you use, make sure that you are consistent. You can't mix spaces and tabs. And I'm going to do win.update. And what that does is every time the loop runs, it updates the screen. Okay. Just a quick note, this program is written for beginners, so I'm not really using object-oriented programming. I'm not really using classes, except as it relates to the turtle module. This is basically a really straightforward, old-school style of programming methodology. So let's run that and see how it goes. And what we should have is we have our title, black background. It is 800 wide by 600 tall. 0, 0 is at the center, so plus 300, minus 300, plus 400, minus 400. Remember those numbers because they'll come in handy in our next few tutorials. So that's all for this particular lesson. I just wanted to get you started. We move on to lesson 2, where we'll add our paddle on the left, paddle on the right, and our ball in the center. In this part of the tutorial, we're going to add our paddles to the screen, and we're going to add the ball to the screen as well. So let's get started with that. So basically what we have in Pong is we have paddle, I'm going to call it paddle A, we have paddle B, and we have a ball. So those are the 3 items that we need to add to the screen. Now, as I mentioned earlier in the previous video, we are using the turtle module to add our graphics and to open our windows and things like that. It's very, very convenient. It works great for basic games. A lot of people use Pygame, which is great, but for simple games, this is probably an easier way to get started. So everything in our game needs a name. So I'm going to call it Paddle A, very original, and it is actually going to be a turtle, what's known as a turtle object. So to do that, it's turtle.capital turtle. Notice the capitalization. Small t, because that is our module name. Capital T, because that is the class name. Now, as this tutorial is aimed at beginners, I'm not going to talk about classes. I'm not writing it object-oriented style. I'm just writing it in functional style, although there are some object kind of patterns here you'll see. But for beginners, don't worry about that stuff for now. So then what I want to do is paddle A, I need to set the speed. Now this is not the speed that the paddle moves on the screen. This is the speed of animation. This is just something we need to do for the turtle module. And what this does is it sets the speed to the maximum possible speed. Otherwise things will be really slow. We want to give our paddle a shape. And there are a few built-in shapes. And we're going to use square in this case. Okay, there's circle, square, let's see, circle, square, triangle, a few others. We're going to give our paddle a color. And we're just going to call it white because that's what Pong looks like. And we're going to basically do something called pen up. Turtles, by definition, what they do is they draw a line as they're moving. We don't need to draw lines because that's not what this program does. So we do the pen up. And I want my paddle A to start at minus 350, that's an x coordinate, and 0 in the vertically centered in the screen. So in our game, 0, 0 is in the middle, minus 350, plus 350. So I'm going to go ahead and run that and see what it looks like so far. Okay, so this is our left paddle. Now, you've played Pong, you've seen the demo from the first video. Clearly, it's not the right size. So what we can do in our program is this. Now, just for your information, by default, that shape is 20 pixels by 20 pixels. So it's 20 pixels wide by 20 pixels high. So what we're going to do is we're going to stretch the shape. So we use the shape size method. And you can see I'm using Visual Studio Code. It's a very good program, even though I'm on a Mac. And it tells you, what you can do, stretch width, stretch length, etc., etc. So what I want to do is I want to stretch the width by 5. So that's going to be 5 times 20. So that'll make it 100 tall and then by 20 wide. And stretch length is going to be 1. We're just going to keep it at the default. So let's save that and run it. Okay, so you can see now we've got a paddle over here, 20 pixels wide by 20 pixels high. Okay, now, so that's paddle A. Now, I'm kind of a lazy guy, so I'm just going to copy this. So what I always recommend, if something's similar styles or similar, functions, get it working right once and copy it, paste it, and just make the necessary changes. So now that we've done that, we just need to change that to B. So if you keep consistent names, it'll really help your programming. In this case, we want it to go on the right side of the screen, so that's going to be plus 350. So I'm going to run that and test it. And testing your program is very, very important at each stage. A lot of beginners, I don't know why, they insist on typing the whole program in and then trying to test it. And you'll never be able to figure out where the problems are, especially as a beginner, unless you do it step by step like this. So we got our left paddle, we got our right paddle. So I said paddle A, paddle B. And then the last thing we need is going to be our ball. So I'm going to just go ahead and copy this because it's basically the same thing. I don't need it stretched. I want to keep it the original size. And I want it to start in the middle of the screen. And I'm going to call it ball instead of paddle. So you can see if you do it like this method, if you get everything working correctly, there's no errors, and you tested it, then you just copy and paste, and it really speeds up your programming. Okay, so I'm going to run that one more time. Okay, you can see we've got our left paddle, paddle A, our right paddle, paddle B, and we've got our ball, which is starting in the center. So we're off to a good start. Okay, so we've got our Pong window, we've got our paddle A on the left, paddle B on the right, and we've got our ball in the middle. So in this lesson, we're going to learn how to move the paddles using the keyboard. Okay, so what we need to do is to basically, we're going to create some functions. Okay, and if you haven't ever used functions before, a function is basically kind of a piece of a program that does something that's been defined for it. So in this case, we want to move paddle A up, we want to move paddle A down, we want to move paddle B up, we want to move paddle B down. Okay, so to use functions, you first need to define your function, and I'm going to call this first function paddle A up. Okay. If you recall in the last video, I talked about doing one function at a time or one piece at a time, getting that working perfectly, and then you can copy and just make the necessary changes. So that's what we're going to do here. Okay, so paddle A up. So to move the paddle, what I need to do is I need to know the current y coordinate. So what I'm going to do is I'm going to say y equals paddle A dot y core. Okay. Now this part here, paddle A is the name of the object. We created it here. We called it paddle A. And the .y core method is from the turtle module. Okay, and what that does is it returns the y coordinate. And so we're just assigning that value to a variable called y, which makes sense. Okay, so we've defined the function using the def keyword. And you notice we have I guess it's a tab in this case. Well, it's a space, we'll see. Might get an error there. And I'll explain that in a second if we do. And it's supposed to be set to automatically change the spaces, but I think it's not set that way, so I'll leave it the way it is. So then what I want to do, if I'm going to go up on the screen, it's this way, so up. So y increases as we go up, it decreases as we go down. So what I'm going to do is I'm going to add 20 to y. And this is the way you do that. You say y plus equals 20. So that will add 20 pixels to the y coordinate. Okay. So now notice we've just calculated the y. So then what we actually have to do is paddle A, set y to the new y. Okay. So now having a function doesn't actually do anything until we call the function. So the function has just been defined, but we're not using it. So what we need to do is we need to do something called a keyboard binding. Okay, so in the turtle module, we need to do wn, so that was our window, and listen. This tells it to listen for keyboard input. Okay. And then we're going to use the onKeyPress method, Okay, and watch what I do here. Paddle A up, W. Okay, so let me explain what that does. So this line here, it tells the program to listen for keyboard input. This line here says, when the user presses W, notice that's a lowercase w, so if you have caps lock on, it won't work. Call the function paddle A up. Okay, and here's our function, paddle A up. Paddle A up says, get the Y coordinate, add 20 to the Y coordinate, and then actually set the Y of the paddle to the new Y coordinate. Okay, so let's test that and see what happens. Okay, so I'm going to hit the W key. Okay, so you can see how it is moving up. Okay, and we can actually move it off the screen. Okay, so now that we've gotten that working, okay, what I can do is I can copy that. Okay, and I'm going to change this to paddle A down. So instead of adding 20, I'm going to subtract 20. And then I need to do a key binding for that as well. So I'm just going to copy and paste that. So this is going to be paddle A down. And in this case, I'm going to use the S key. You can use whatever key you want, but I've just chosen those, because usually it's WASD on the left and the arrow keys on the right. So again, I've done one thing. I've changed it. Now I'm going to test it. Okay, so W, S. Okay, so everything's working exactly as expected. Okay, so then what I'm going to do is, now that I've got both of those working, I'm going to copy it, and I'm going to do paddle B, paddle B, paddle B. So if you keep your naming consistent, it makes it very, very easy to do what I'm doing, which is to be lazy and just use copy and paste. Okay, and then here, now for paddle B, I'm going to use the arrow keys. And then for the up arrow, it's a little bit different. Use up, notice it's capitalized, and down is the down arrow. Okay, so again, I made a couple changes. I'm going to test my code. Okay, so WS on the left, up and down on the right. And voila, there you have it. Removing the ball. This is really kind of the meat and the central kind of part of the program. This is where we actually get the ball to move. So we need to get it to move, we need to get it to bounce off the top and the bottom, and we need to get it to bounce off of the paddles. And so I'm going to show you how that's going to work, because we have our paddles can move, but the ball does not yet. So let's get started with that. And so what I want to do is, with the ball, is I want to separate the ball's movement into two parts, an X movement and a Y movement. So what I'm going to call that, I'm going to say ball.dx. D means delta or change. You can call it X speed or whatever you want to, but dx works very, very well. Now on my computer, I found that the number 2 works very, very well. My computer at home, actually it was like 0.1. It's much, much faster. I don't quite know why. So you might have to play with the numbers here to get it, to where you feel the game should be. So dx and dy equals 2. So what that means is every time our ball moves, it moves by 2 pixels. So since x is positive, it's going to move to the right 2, and since y is positive, it's going to move up 2. So it'll be kind of moving up and diagonally. Okay, so to get that to actually happen, we have to go inside the main game loop. Okay, and in here, I'm going to say move the ball. So what we need to do is ball.setX, okay? And what we want is the current x coordinate. So I'm just basically kind of combining what I did up here into one line, plus ball.dx. Okay, so the ball starts at 0, 0, so 0x. So the first time through this loop, it's going to go 2. And then the next time through the loop, it's going to go 2, 2, 2, 2, 2. So depending on your computer speed, it could just fly off the screen, or it could go a little bit slower. So again, you'll have to play around with that a little bit. So then I'm going to say ball.setY. And basically the same thing. I could have copied and pasted, but I should have done. And ball.dy. Okay. So I'm going to save that, and I'm going to test it, see what happens. And you see some red lines here. I think there's going to be maybe a problem. Yeah. So I'm going to run that, and I'll explain why it's not going to work. Okay. So you can see here I've got an error. And this is something, again, beginners, I don't know why, do not want to read error messages. The error messages basically tell you what's wrong. So you see here it says tab error, inconsistent use of tabs and spaces. Okay, so I mentioned this in an earlier video. So here I used 4 spaces, but here it's a tab. Okay, you got to use the same thing each time. So I'm going to go with 4 spaces. That's actually the preferred method. Now I can set my editor up so that when I hit a tab, it changes to 4 spaces automatically, but I'll do that another time. Okay, so I'm going to run that, and hopefully we'll see the ball move. Okay, so plus, it's going plus and right off the screen. All right, which is what we expected. Okay, so that's good. So now what we need to do is we need to do some border checking. So what do we want to happen when the ball hits the border? Okay, so since it's moving up and to the right, we'll do the top border first. Once we get the top border working, then it's easy to get the bottom border working. Okay, so what we have to do is we have to compare the ball's y-coordinate. Okay, so once it gets to a certain point, we want it to bounce. Okay, so if you recall earlier in the program, we set the height of the window to be 600. So that means that the top y-coordinate is plus 300, the bottom is minus 300. Okay? But the ball itself is 20 high by 20 wide. Okay, so what we'll do then is we'll kind of split the difference. So we're going to say if the ball.y-core, so if the current y-coordinate is greater than 290, okay, colon, and I got to use spaces. It's telling me. 1, 2, 3, 4. If it's greater than 290, what we do is we set it back to 290. This avoids certain types of problems. And then what we need to do is we say ball.dy times equals -1. Okay, and what that does is it reverses the direction. Okay, so if dy is 2, so dy minus -1 is -2. Okay, and that should reverse the direction of the ball. So let's run that. Okay, so let's watch it, and boom. Very good. That's exactly what we wanted to happen. Okay. Now, since this is working exactly as we want it, I'm just going to copy and paste that and just make some changes. So on the other end, if it's less than -290, we set it to -290, and that is that. So let's test that. To test that, we'll need to start the ball off with a -dy for now. And again, notice how I'm making a change, testing, making a change, testing. Okay, it's working. That's about what we wanted. It was a little bit off screen there, but we'll let that go. So that's the borders. That's the top and bottom borders. Okay. Now, the next thing we need to do is the left and right border. So this is where it gets not more tricky or anything, but you got to think about what we want to happen. So in this case, because we're looking at left and right, okay, we're not looking at the y-coordinate, we're looking at the x-coordinate. And now what we want to do is if the x-coordinate, basically if it goes off the right side. So if you remember, we said the width was 800, so that means it's plus 400 on the left, minus 400 on the right. So let's say if it's greater than, we'll say 290, or sorry, 390. So that tells us it's gone past the paddle, and it is off the screen. Okay. And what do I have? Okay. So if that's the case, okay, basically we're going to put the ball back to the center, 0. And then what I can do is I can maybe ball dot dx, may have it reverse direction. Okay, so let's take a look at that. Again, I'm testing it to make sure it works, and if it does, then I can copy and paste and do the other side. Okay, so we got an error. Okay. So it says we got a lot of weird stuff here. That was a really long one. And you say here. So you say it says line 87. So here's the line where it thinks the error is. And there's a lot of different weird stuff. But basically what I forgot to do was 0, 0. Okay, so let's test that again. So it should go off the screen. Okay, now it went back to the center and reverse direction. Okay, so we know it works. So let's copy that. And paste it. And now again, we're just going to reverse it. So if it's less than negative 390, and that's all we got to do. Okay, so again, let's test it. Hopefully it will come back. Okay, so that's basically, yeah, that's exactly what we wanted to happen. Okay. So in this lesson, we're going to learn how to get the ball to collide with the paddles. So let's see what we have so far. So we've got our ball. It's bouncing off the top of the screen, and it's at the edge of the screen. It goes back to the center, which is what we want. So what we got to do is we got to make it so that when it touches the paddles, it will reverse. And how we're going to do that is basically what we're going to do is we're going to compare the x and y coordinates of the paddle and the ball. So if we look at our code, we put paddle B at 350. So the x coordinate of the center is 350. And if you recall, the center, it's 20 pixels wide by 100 pixels tall. So we need to basically look at, we need to make sure that the ball is basically between here and here, and that it's basically between here and here. And if it is, then we'll call that a bounce. Okay, so let me kind of play with the math a little bit on that and give that a shot. So let's again, as I mentioned before, we're just going to try and get the right paddle working. And if we get the right paddle working, then it's easy to get the left paddle working. Okay, so I'm going to say, so paddle and ball collisions. Okay, so if the ball.xcore, so if the ball's x coordinate is greater than, so we said 350, it's 10 wide, so it's greater than, say, 340, and the ball, well, actually, I'll leave it at that. I'll leave it at that, and then we'll come back and fix it in a bit. So that's one condition, and the ball's y coordinate is less than paddle B dot y core plus 50. Here's a lot of stuff in here, and there's a lot of different things here. Ball dot y core is greater than paddle B dot y core minus 50. Okay, so I'm glad that's scrolling over. So let me explain that real quick. So if that's the case, okay, I'm going to tab there. 4. If that is the case, basically we just want the dx, same thing we did at the top, times equals 1. Although this is x, not y. Sorry, negative 1. So if it's going this way, the dx is positive, it's going to bounce and go back this way. So what we want to see is the ball x coordinate greater than 340. That means the edges are basically touching. And is it between the top of the paddle and the bottom of the paddle? Actually, think it should be 50. It should probably be 40 because of the size of the ball. But let's play around with that. Let's test it out, see what happens. Okay, so I'm going to run that. Oops. Okay, so did you see what happened there? Which is not what we wanted. Okay, see, it bounced there. But watch what happens. If I miss it, see, there's like a little bit of a glitch there. It's because, even though it's behind, the x-coordinate is greater than 340, and it's between here. Okay, so you see how that's kind of acting weird. So what we need to do is I'm going to add this condition. And ball.xcore is less than, we'll say, 350. So that gives it basically to the middle of the paddle. So we'll say ball.setx to 340. So that moves it back to the left a little bit. And then it reverses the direction, which is what we wanted. Okay, so let me test that one more time, make sure it's working. So it bounces, which is good. Let's let it get past and see. Okay, so you see how it did not get stuck that time. So that's basically what we wanted to happen. So let's just test it one more time. Yep, so that's where we wanted it. Okay, so I'm just going to basically take this, I'm going to copy it, paste it, and I'm just going to do the same thing on the other side. So minus 340, greater than minus 350, and the top and bottom doesn't matter. But in this case, it's going to be paddle A, not paddle B. That would give you definitely some weird glitches. And then same thing, we're going to reverse the ball. So let's test it again. Okay, so over here, we're using the up and down arrows. Okay, it bounced. Over here, we're going to use the W and S keys. And we test it. Okay, so something went wrong there. So I know what I did wrong. So I had set X here to 340. It should be negative 340. So again, notice, because I'm testing it, after every little bit of code, I knew that the problem had to be in here somewhere, because that's the only thing I changed. I can't emphasize that enough, because my students, like I said, they always want to type the whole thing in and then debug, which is never a good idea. Okay, so let's test it one more time. So you can see this process. We're iterating, we're testing, and just making sure everything is working as expected before we move on. Okay, so that is that for that section. So now we've got colliding with the paddles. It's going off the screen. The next thing we need to do is to add some sort of scoring mechanism. So here's what we have so far. We've actually got a functioning Pong game. The paddle on the right is moving using the up and down arrows. The paddle on the left is moving using W and S. The ball's bouncing. It's doing everything it needs to do. Next, we want to add a scoring system. So let's go ahead and take a look at that. So basically what we want to do is we want to draw the score on the screen. And here's how we're going to do that in Python using the turtle module. So what we got to do is we actually got to create a pen. Okay, I just call it a pen, but it's actually just a turtle, just like the ball and like the paddle. But the turtle module gives these turtles objects a lot of different abilities. So I'm going to make a pen, and it, like the other, is a turtle.turtle. Again, I always spell that wrong. Again, keep an eye on the capitalization. So small t for the module name, capital T for the class name, which it's happening in the background. Same thing as before. So pen.speed. And again, this is the animation speed, not the movement speed. It's not really going to move, but we're going to give it a color, pen.color. The shape doesn't matter because we're not going to see it. If we want to print in white on the screen, like classic Pong style. And pen.penup. This is because we don't want to draw a line when the pen moves. Every turtle actually starts out at the dead center of the screen, then we move it somewhere. If we don't do pen up, you'll see a line moving. between those 2 points. And then here we want to hide the turtle, because we don't need to see it. Now with the ball and the paddles, we didn't hide it because we want to see those on the screen. But with the pen, we don't want to see. We just want to see the text that it's going to write. So pen.goto and 0, I think 260. And again, I played around with the numbers. That's why I know 260 is the number I want. If you remember, again, the screen height is 600. So that means it's 0 to 300 here. So we want the score to be right around this part of the screen. And then it gets pretty easy at this point is we use the write method. So we want to write, and I'm going to write player A. And now when the game starts, the score, of course, is 0. 2 spaces, player B, 0, comma. And then you want to align equals center, because that will center the text for us around that point. And then we want to choose a font. Okay, now watch here. I've got an extra set of parentheses here. Okay, don't forget that. And I want the font Courier, because that's kind of old school techie. I choose a font size of 24 and normal. I think you can choose bold and italics. I'm not 100% sure on that one. Okay, so be very careful. Again, we've got a set of parentheses here, and we've got an extra set of parentheses here for the font. So because there's 3 arguments we got to send there. Okay, so again, now test your code. Make sure this is working. So I'm going to run that. Okay, so that's what we wanted. You see, I forgot the little space after player B. Okay, but yeah, that's basically what we wanted. Okay, so that's how we get the default score on the screen. So now what we got to do is we need to keep track of the score. And so what I'm going to do, and I'm going to put this up here, and score. So I need to create a couple variables. I'm just going to call it score A, and when we start the game, it's always 0. And score B is going to be 0. Now, down here, okay, so we get a score when the ball goes off the screen. So here's the right side. So if the ball goes off the right side, think to yourself, who gets a score? Of course, that is going to be player A. So what I can do is score A plus equals 1. That adds 1 to player A's score. And by the same token, on the other side, if the ball goes off the left side of the screen, player B gets that. Okay, so let's run that. Oops. Okay, so nothing, we don't see any change. Can you guess why? Okay, now if you said, well, we didn't update the score on the screen, you'd be 100% correct. Okay, so what I'm just going to do is I'm going to copy this line here, and I'm going to put that into here. And you'll see what I got to do is instead of the zeros, and this is just print, basic printing, 101. So if you're not sure how to do that, I do have a video on that somewhere. I'll try to remember to link that below about how printing works. So we use the format method on our string, and we want score A and score B. Okay, so what that does is it puts score A here and score B there. So I'm going to, again, make sure I'm using spaces. I'm going to copy that, because I'm pretty sure this is correct. So basically, every time I update the score, I need to update the actual printed score on the screen, or the shown displayed score, I should say. So I'm going to run that. Now watch what happens here. Okay, so you can see it did update. Okay, but clearly something is wrong. Okay, because basically what it's doing is it's just printing on top of itself. Okay, so what we have to do is before we call the write method, we say pen.clear. Now we'll actually clear what's on the screen. Okay, now it happens so fast that you don't see it, but it actually does. So take my word for that one. And again, if you're using Pygame or some other framework or method, you might not have to do this type of steps. But for the turtle module, this is what you need to do. Okay, so I'm going to run that. And let's watch what happens. Okay, so player A just got a point. Player B just got a point. And so on and so forth. So, yeah, so basically we've got a pretty well working game here. Again, the game never ends. You just go until you give up and get bored, which is pretty easy with Pong. I've got another tutorial coming up on this in this series. I'm going to show you how to add a little bit of sound, which is interesting, especially depending on the operating system that you are using. I'm going to show you how to add a little bit of sound to your game. So just basically, what you need to do to get started with that is you need to have a sound. You need to have a sound file. And what I've done is I have downloaded this file from I forget the site now, but it is bounce.wave, and it's like kind of a classic old school bouncing sound. You'll hear it in a minute. Now, Python is generally pretty cross-platform. Basically, everything that we've done so far, it doesn't matter which operating system you're using, Linux, Mac, or Windows, everything works the same. Sound is one of those things where it doesn't work the same. So right now I'm on a Mac, and I'm going to show you how to do it on a Mac, and then I'll talk about how you would do it then on Linux or Windows. Okay, so it's a bit different. Okay, so the first thing I got to point out is that the sound that I found, bounce.wave, and wave files generally are more compatible, cross-platform compatibility, is in the exact same folder as my Python file. So right now I'm on Pong 7, and Pong 7's in there. So they are in the same folder. That's a really important point. Now that you can work around that if you know what you're doing, but for beginners, this is probably the easiest way to do things. And so basically, it's really simple. When do I want to play a sound? And so I'm going to play a sound when how can I put it? When the ball either touches one of the borders or bounces off of the paddle. Okay, so in Mac, okay, so I'm going to use something called the OS module, and what that lets us do is basically interact with the operating system through text commands. And so I've imported OS, so I can use that module. And then down here, so what I can do is I can say os.system. That will do a system function call for us. Now on Mac, it's aplay bounce.wav. Okay, so this is it. This will play the sound when it hits the border. Now there's a problem here, and I'm going to show you that in a second. But again, let's test it, see what happens. Oops, went the wrong way. I have to wait till it hits the top. I'll turn my volume up. Oops. Sorry, my bad. aplay is for Linux, afplay is for Mac. Let's try that again. Got that backwards. Had a 50-50 chance, and I blew it. Okay, let's listen. Now, did you notice that everything stopped while that sound played? So watch it again. Okay, that is not what we want to happen. Okay, so to get around that, at the end of this command, we need to add an ampersand. That's the and symbol. Okay, so again, let's test it. And now watch, it will not delay. Okay, so it's a little bit off, but that's, neither here nor there. I suppose we'll have to deal with that. Okay, I think actually what I would probably have to do is edit this wave sound. There's probably a little bit of a blank space at the beginning of it. So that's it on Mac. Okay, so let me copy that, and let's say we want to play it when it bounces at the top, bottom, and when it touches the paddles. So we just need to put, oops, why did I do that? Okay, so let's test it. So again, I got it working once, now I just copy and paste. So it should bounce here. Oops. Missed that. I'm terrible at Pong, apparently. Okay. Now you could choose different sounds. You have one sound for when it bounces off the walls, one sound for when it bounces off the paddle, etc., etc. Okay. Now, if you are a Linux user, the system is very, very similar. Instead of AF play, it's A play. And that's all you have to change. Okay. Now, if you're on Windows, it's a little bit different. Now, I can't test it for you, but I can explain how it works. And I do have a video that explains this, and I'll try to remember to link that down below. And basically, in Windows, instead of importing OS, you import WinSound, which is a little module that only exists on Windows. And then when you want to play your sound, instead of this os.system stuff, you would type winsound.playSound. Again, pay attention to the capitalization. Okay, small w, capital P, capital S. Then in parentheses, so you don't need the ampersand here, but you do need a comma and then winsound dot snd async. So what that does is that same thing as adding the ampersand. That'll stop. If it's asynchronous, it'll play the sound in the background. If it's not asynchronous, program will stop. Again, I can't show this to you because this is Mac, but that should do it. So I'm going to undo that and get back to my system. Oops, that's not what we wanted to. Oh yeah, keep going. Yeah, A play and it's AF play. Let's leave that. I'm going to test it one more time, and that is our Pong program. Okay. Yeah, not the most exciting thing in the world, but you learn a lot of different concepts. How to put objects on the screen, how to move them with a keyboard, how to detect collisions, update the score on the screen, game main loops, sounds. So basically all the basic elements that you need to make a game are included in Pong. That's why it's one of the classics, and I remember playing this as a child. It brings back some memories.